there's really only so many bona fide data center developers that are actually going to go soup to nuts and deliver what the end user needs or what the hyperscalers and these newer builds are looking for. Everyone else is effectively just a broker.
Welcome to another edition of Not Your Father's Data Center. I am your host, Raymond Hawkins, Chief Customer Officer at Compass Data Centers. Today, we are joined from the great state of Ohio, Dan Cook, the founder and managing director of Solarstone. Dan, how you doing?
Doing well, Raymond. How you doing?
Good, good. So today we're going to talk about data centers. We're going to talk about solar power. We're going to talk about generation and transmission and distribution and all of the things that the data center business is doing to our grid. But before that, we would love to hear a little bit about you. Is Ohio home? Have you always been in Ohio? Go back as far as you like. We'd love to hear about you and how you decided to get in the solar business.
Yeah, absolutely. I appreciate it. At the top level, my company, Solarstone, we are utility scale solar and battery developers for the most part. We currently are working on about 2 gigawatts worth of projects. Ohio is home. I'm born and raised in Cleveland, and that's where I decided to set up shop. Really starting Solarstone, for me, we were always development minded and focused. Really didn't start developing our own projects until really 2021, 2022. And, I myself did not come from a development shop. I think that's, somewhat unique in the development world, especially as this industry has grown so much. I got my start, really in the commodities world. I was a metals trader and started off working base metals, copper, aluminum, nickel, lead, zinc, those types of things. And we had a lot of clients in the physical space, and it was a fast, stimulating environment. I really enjoyed it.
I'm gonna get you to pause on the metals thing for 1 second. Well, I watched a clip yesterday about, and it was the CEO of a large copper miner, and he made a statement that blew me away. So hearing that your metals background, I'm going to get you to address it if you don't mind. Mm-hmm. He said that we are going to have to mine and produce as much copper in the next 18 years as we have in all of human civilization, based on how much copper goes into technology today. That number was just blew me away. Even if it's not 18 years, directionally, is he right? Is the demand gone up that high?
Absolutely. I think when you look at the electrification narrative at large, copper really is the winner, and copper should be seen as kind of the biggest concern. I've seen all kinds of numbers and projections on this over the last 4 to 5 years. Those numbers sound accurate. I mean, I'd have to get into the nitty-gritty.
Directionally, he's right.
He's absolutely right, 100%.
Because he made the comment about recycling, and I know we're here to talk about solar, but interesting that it's all our industry is constraining the world, and I had not heard this copper constraint. He said, look, if we took all the copper out of all the buildings in the world, it would help. But he's like, obviously we can't do that. They're all the infrastructure is built. That copper's all staying where it's staying. We got to find all net new ore. And I just, that blew me away. 18 years, the same amount of copper as in all of recorded history, which was just shocking.
Absolutely. And the grade qualities have been going down, the legacy mines, the legacy assets, it's natural resource economics. There have been ways to improve upon those existing mines and technologies. But, the mining sector has a big outlook and some big shoes to fill to really meet that demand.
Well, you piqued my interest with being in the metals, commodity metals, but keep going because I interrupted you, but I had to ask when you brought it up. Yeah,
absolutely. I mean, and it still informs my perspective somewhat. I mean, you take what we deal with on the battery side, and now how critical minerals are such a massive part of our conversation it's a national security issue at this point. And there's a lot of people, in the government and in the private sector trying to navigate that. So that perspective was always and still is incredibly valuable to me. What really happened as I got that start, and I mentioned it was a small shop. So looking at different channels of business, different ways to grow. at that firm, I started basically the energy brokerage side of the business, essentially brokering electricity and natural gas contracts, conventional contracts for the most part, to our metals clients, some of whom were very large loads. I mean, we talk about large industrial loads today. 20 years ago, even 10, 15 years ago, a large industrial load was an aluminum smelter. It was a steel mill. It was, the typical heavy manufacturing, dirtier industries that, people.
Yeah, that was as intense a load as you would get.
Absolutely.
That's as high as
you might have had 100
anywhere.
megawatts for, a steel mill or a mini
Right.
mill and giant arc furnaces and very significant loads at the time. Now 100 megawatts is, year one for a new data center potentially. Right. So,
Right. Yeah. Yeah. Our industry has certainly caught the generation business a little flat-footed, and I don't mean that disrespectfully. It's gotten so big so fast that how to communicate, collaborate, plan, and grow with our industry is really, the power world is spinning a little bit, which will lead us to the business you're in today. Yeah.
Well, absolutely, and I think it's not only caught the generation business a little flat-footed, but the transmission business, right? And
for sure,
the utilities. I think my understanding is historically, the data center folks are looking for good interconnects. They're looking for speed to power in a conventional sense, where the utilities have capacity and they're able to, bilaterally negotiate a good position and good transmission service. Whereas I'd be hard pressed to find that exists today. And even in the last 12 to 18 months, since we've become more aware of what the data center industry needs, the transitions to, going behind the meter and having to bring your own resources, bring your own capacity, it feels like that even happened quicker, than we anticipated. So when you look at the generation industry, because they are, at least in most of the country, largely decoupled, the provision of power and energy, the interconnection queues for new generation assets are as high as they've ever been. I mean, they're bloated, quite frankly. And the queues themselves have had to deal with an insane amount of backlog. Queue reform to get rid of speculative projects. They've increased the costs for basically every technology everywhere in every single market. But the lead times aren't coming down, right? When I started in this industry, you could still potentially get, a new power plant up and running in certain markets on a 3-year timeline. Now, I think that average is easily 5 years. It's not going the right direction. It's not going backwards. It's really just continuing onwards. And we've got projects that are a part of that timeline 6 years before they'll hit operations. It's the new normal.
So some of that's equipment, right? Some of that's gear. What are some of the other reasons, Dan, that you see that queue drawing out so much?
I think it's a couple things. It is the sheer amount of projects. I mean, the grid operators themselves, I don't think were equipped, and the processes that they have were just not equipped to deal with hundreds upon hundreds of queue applications. So there is that sort of raw kind of headcount, talent, workforce to be able to do the work. But then you also get into, developers or projects that sort of start gamifying the queue, if you will. Historically, you design your project, you pick your point of interconnection and say, okay, we're going to see how much it costs, how much of the upgrades we need to shoulder in order to get that project online. Those costs are somewhat socialized across all the other projects in your queue, in your cluster, in that grid operator. So it's hard to get a true picture of what the interconnection costs might be if 80% of the projects might withdraw in the middle of the queue process. So that's caused a significant amount of delays. I would say equipment historically hasn't always been the limiting factor. Now, you look at breakers and transformers, there are some very long lead times for those components now. But just the sheer amount of projects and the way the queue process was designed, 10 years ago, even 20 years ago, and how it's continued to exist versus how it actually functions, they broke it essentially.
Yeah. The industry, we get asked this one a bunch, and I always tell people, I said, look, when a developer was building a neighborhood with 800 houses, when he was done, that development might have needed, 5 megawatts or, to run the whole development. So getting him delivered power fit in the model for the grid and the grid operator on the generation side, right? When you show up and say, I need 2 gigawatts, that doesn't fit in the model, right? That wasn't like, oh yeah, we've had 2 gigawatts on the roadmap. It'll be fine, right? It'll no problem. It'll fit in. We got to turn this knob here and dial that over there, and it'll all be good. The sheer scale has just completely destroyed the models. And then to the point I think you alluded to, the other one is not all of these data center projects are legitimate data center projects. In other words, because there's so much talk around our industry, there are lots of speculative demand in the system that I still think has to get cleaned out. And I think it's why we see the generation guys asking for so much more financial wherewithal and commitment on the front end to try to weed out so much of that speculation, because I think it's really hard to tell what the real projects are still.
Absolutely.
It's getting better. It's getting better, but it's still not perfect, the system, for sure.
Well, and in some ways, the data center folks are dealing with what we just dealt with, or what we're still dealing with on the generation side, is having speculative projects, having an incredible amount of incentives offered to the industry. 3 years ago, 4 years ago, when the IRA came out, and I'm still obviously pro incentives for my own industry and my own technologies that we develop, but everybody and their cousin who had a backyard 40 acres with a transmission line on it said, great, we're doing solar, and
yeah,
I suspect at least what we've seen or heard in the data center world is that it's similar. You get a lot of the real estate folks that hear these, elevated valuations on $1 per acre basis, and they say, great, I want a piece of that. What do I have to do? Well, just because you might have a potential interconnect and some land, doesn't mean you're going to be able to drop a data center down there. From at least what I've seen in interfacing with this industry, is there's really only so many bona fide data center developers that are actually going to go soup to nuts and deliver what the end user needs, or what the hyperscalers and these newer builds are looking for. Everyone else is effectively just a broker.
Lots of speculators out there, Dan. Lots of speculators. Lots of speculators. I would tell you, when I got, so I've been in the data center business about 13 years. When I got in, there were fewer than 300 data center companies on the planet, right? Doing genuinely delivering data center capacity. Today, there's about 4,000.
Yeah.
So, and it's just, it's been a mad rush, right? And that's only counting people that have actually delivered. If you count people that say they can deliver, it's probably about 12,000 that have never actually delivered anything. So yeah, it's crazy. So I do want to, you mentioned batteries, you mentioned behind the meter, you mentioned everybody who thinks they got an error, hey, there's a high voltage line running across my property, I'm going to get in the business. Are you? Okay. That's okay. That's somewhere to start. It's maybe, so talk to me, because when I pull an electron off the grid, I don't want to say I don't care. I don't know where that electron came from, right? I don't have electrons that show up and say I'm a hydro electron, I'm a nuclear electron, I'm a solar electron, and I'm a coal-fired electron. I just get some energy.
Absolutely.
So can you talk to me as I'm not an energy guy at all. Can you talk to me about where Solarstone fits in the model? I think of, so I live, in the deep south. So, I got the TVA who does lots of generation, and they, pump that generation out to all kinds of different electric, companies, Georgia Power, Mississippi Power, Alabama Power. Can you kind of talk the folks that are listening through, where does Solarstone fit? Because when I think of power, I think of the person who sends me my power bill, or I think of Georgia Power or Alabama Power who's doing the generation. Where does Solarstone fit in that model?
Definitely. And I'll sort of bifurcate this, because there's, given, the oversupply of renewables projects and how many of them are on the grid, it makes sense that, the average data center is going to be technology agnostic, right? I mean, that's, at the end of the day, those clients have their own, those users have their own requirements, and, they don't always have the leeway to be preferencing certain technologies, apart from maybe a few that are trying to sort of virtually, offset their exposure or manage their, carbon
Right.
and emissions. But there's two ways to think about this. When we look at the average solar project, obviously we're, not able to ourselves power a full data center for, 24/7 or high up times that, which is my understanding of what these facilities require, and even solar plus storage won't accomplish that either. We can talk about long duration storage and it's being piloted. There are projects that are moving forward, but again, it's not going to supply on a single or even hybrid technology basis everything that you would expect a data center to need. But it absolutely, I think, can be a part of the mix. Now, I'll get back to that in a second, because there are plenty of renewables developers, power developers in general, whether you look at the large IPPs down to the small shops like Solarstone, where they see the writing on the wall and they look at, okay, this is a moment for the power industry. These people need power. Great. That's what we do. How do we provide that? And the shift back to thermal assets is very clear. It's not the, the dominating technology that's being developed for all of these projects. Or it's not as if renewables developers are cutting all their, solar and wind, but they are looking at more of through the lens of a powered land strategy where, okay, well, you guys need a couple hundred acres, you need to get interconnect, you need heavy power. Those are all the things we look for on any given project. Is there ability to transition that project to be something else? Is there an ability to take an early stage position and partner with somebody in order to provide that? I would be hard pressed to find a single developer in the renewables space that has not looked at their portfolio and said which one, how many of these fit that bill, how many could serve those loads or transition to data center projects. And I say that from my own experience. We're not exempt from that. We've got one or two sites that look like they check those boxes. Are we going to dive headfirst into, hey, we're data center developers? No. But when we look at what those facilities need, there is something we may be able to offer. You look at the capital markets, you look at the supply of projects, and there is a very clear sort of transition or pivot to people now pursuing more gas projects, really going back to those more traditional thermal projects. And at this point, if they're looking to serve data center load, they may not be all that traditional anymore. And that's where, maybe the behind the meter conversation comes in. But back to the solar piece of this, we do see, some hyperscalers or some of these loads looking for, still looking for solar, still looking to include that as a part of the generation mix that, they're going to use to serve the load. And whether or not that's still, grid connected, it's hard to say. I mean, all of our projects are grid connected. I don't know how many, data centers or developers may be contemplating behind the meter solar.
Can we talk about that one? Can we talk about that one for just a second? I'm going to run the Compass narrative of grid connected versus behind the meter by you. Mm-hmm. And as a generator guy, a guy on the generation side, I would love for you to either shoot holes in my position or advise us on the way we think about it. We think that there's already PR challenges in our industry, right? We're a big utility user. We're a big energy user, which means that we have a big carbon footprint. And we don't want to be viewed in the industry as, hey, we're here to make sure that the utilities serve us. We recognize that what we're asking of the utilities is lots of development, and we want to go do that together. We want to say, hey, we're going to show up and we're going to be a ratepayer like any other ratepayer. And not only are we going to be a ratepayer, but we want to help mature the grid. We recognize that our industry has shown up and put a lot of stress on the grid. And what can we do to co-develop, co-plan, co-spend, help build substations and help build, transmission lines and help build, distribution. We want to be part of the solution. And we think that story is harder to tell if we do behind the meter. In our world, would it be easy? Hey, we're going to go build that power plant ourselves, or we're going to set it behind the meter. And it feels a little bit like we're going to take our toys and go home, and that we're not helping the broader story. That's how we think about it. You being a generation guy, does that make sense to you? And I want you to hear too. We believe part of what we're trying to do is manage a PR story. We recognize we're heavy power users, and we want to not do anything to damage any ratepayer in any market. We actually want to help in that regard.
I think managing the PR is obviously sound. I mean, and all developers have to do this, even on the renewables side, which you would expect doesn't, run into those same difficulties. We have a whole other array of issues and feedback and pushback on permitting and siting and whatnot. So managing the PR, it's an imperative. But then there's also a whole range of, utility kind of positioning or even policy driven, largely at the state level, that is making it such that you guys are going to have to do that anyways. There's new specialty large load tariffs. There's, the kind of bring your own capacity movement and all these different things. I would suggest it's, largely going to be driven by what the end user, what the end customer wants or requires. At the end of the day, if they're saying, hey, it's speed to power, and you go find us the top 10% that can deploy as quickly, efficiently, and reliably as possible, and if they happen to be behind the meter, I would go back to your point of you're agnostic on the electrons anyways, so are you equally as agnostic on the grid? The key, I think, here to sort of point out is that electricity prices are going up. I mean, that's a Main Street narrative right now. And whether or not they're going up because of data centers or not doesn't particularly matter, because perception is reality. If they're going up and someone said, great, there's a gigawatt data center up the road and we'll blame them, then that's what gets the blame. And renewables have dealt with this, for a long time, where all the issues on the grid, it's our fault because we're intermittent and the queues are clogged, and now it takes 5+ years to get a project, and it's because all the renewables developers screwed it up.
Misery loves company, Dan. I'm glad it's not just us.
Well, I'll say it happened quicker to you guys than it did to us. I think there was sort of this incremental rise with renewables where it was economic in certain areas. Component prices kept coming down. Power prices, gas prices went a different way, over the past 3 to 4 years, given some of the macro factors affecting those. But it happened to you guys pretty fast. I'm surprised, even just in the time that I've been aware of more intimately what the data center industry needs. I've been in counties where you'll see signs, you'll see, no data centers in our backyard, and I didn't necessarily expect to see that because the projects are just so large and the impact that they have on economic growth is now so clear. Now, to your point on the kind of behind the meter versus from the meter, I hadn't necessarily thought about it that way. I think there's a really interesting case where that owning that front of the meter narrative and saying, we're here to make things better. We're not necessarily here to just island everything and say, leave us alone, give us our permits, and, we'll pay some taxes or not. I think that's an interesting perspective. I'd be curious to see how quickly, those projects can, accelerate or bring those improvements or really have an impact on the grid. Because again, the grid's the grid, and what's equal of generation is at least somewhat true of the load side of the equation as well. You'd expect load to be preference at some point. Ultimately, these are the end users here.
Yeah, the phrase we're trying to get the industry to say is, hey, we're not here to be served. We are here to serve. There are things that we can put in the context of our projects to help the grid, not just, hey, there's the line, give me everything I need on that line right there, and just I don't want to hear anything about it. We recognize we are causing all kinds of downstream challenges, and we want to be part of the solution in those downstream challenges. And if anything that we can do to hold the line for the traditional retail ratepayer, that's what we'd like to do in every market that we enter, because we also recognize we are usually a pretty special customer when we show up. We're usually the biggest, ratepayer pretty quickly in a state. We develop at the campus level. So for us, we develop anywhere from a 300 to megawatt to a gigawatt facility. Mm-hmm. And so we quickly become a very top 3, top 5 user in the state really fast when we show up and want to be part of solving the grid problem, not just be served. That's the way we're trying to think about it.
I think there is opportunity for that. I mean, when you look at maybe where projects, some of the, new areas that you can cite projects, you're effectively creating new load pockets, and that's going to, maybe alleviate certain constraints on the grid on one side. And sure, there could be trade-offs elsewhere, but I do think there is an opportunity, to be part of the solution and not just to have that, being served mentality. And I guess to go back even to that positioning on front of the meter versus behind the meter, I would imagine, and you correct me if I'm wrong, if there's a lot of behind the meter, projects that are saying we're going to deploy that way and we want to remain that way indefinitely, my understanding is that's not really the strategy. I mean, there's probably going to be a grid connect being pursued in parallel anyways. So,
that's right. And I'm going to stab in on that one for a second. Yeah, it's almost always bridge. It's almost always get me there. Give me 2 years, give me 3, maybe give me 5. And really two things. One is speed, like you alluded to earlier, is, hey, let me get power quickly. And then the other one is, these are long-term leases, but the don't want, a 15-year power agreement necessarily, unique to behind the meter. Let's get on the grid and let's get part of the normal power procurement process. Let's not have our special own thing that's indefinite. So I think there are a couple forces that keep people away from, hey, I'm behind the meter forever. You're definitely right there. I want to remind myself, I like to talk about long-term storage because as a solar guy, I'm sure it's on your radar. But before we do that, can you tell me what a Solarstone project looks like? You mentioned 2 gigawatts worth of development. And a couple of things that come to my mind. How big is it? Meaning how many megawatts? How big is it? Meaning how many acres? What's a normal location? Because I think of these, I split my time between the Southeast and Texas. I go out to West Texas where there's lots and lots and lots of flat land. And you see arrays out there. So what, and certainly on the West Coast. So can you talk me through what does your project look like? What does a project look like? And then who's your end user? Who are you signing a contract with?
Absolutely. So generally our projects, typically 100 megawatts and above per project. If we ran the average, it's probably somewhere around 150. We do occasionally have projects that fall below that threshold. What we look for very much similar things, right? And it's one of the reasons we're having this conversation. Flat land is obviously important, but good interconnects are really what drive, the project value for us, in addition to good offtake opportunities. And that's where, the revenue side comes in. With our shop specifically, we're focused pretty heavily in middle part of the country in both SPP and MISO. We have done some projects in WEC on a state-by-state basis historically. And PJM is still, a decent market for us. It's not one that we've, got a lot of mature projects in, but we'll probably be revisiting. So those are really the 3 or 4 markets that we like to focus on. You mentioned TVA. We do actually have a project in TVA territory as well. When we look at the fundamentals then of what are those projects composed of, you mentioned land. I mean, the historical rule of thumb for solar is 5 acres a megawatt. So when you look at that proverbial 100 megawatt project, it's at least 500 acres and typically going to be more because you're obviously going to want to have some breathing room, setbacks, permitting, any geotechnical issues or anything else you might run into. For storage, that changes quite a bit. It is a much more energy dense application, as you would imagine. And we've got storage projects as small as 5 acres. Now, generally, we like to have 10 or 20 or 50, but that's driven by the land constraints, what you can get, what the interconnect looks like, and ultimately the size project you're contemplating. But, that looking at what our portfolio is today, at 2 gigawatts. That's down from a peak of 4 gigawatts that was backed by probably at least 10,000 acres of land positions. So would it be right to say that's exactly cut in half on the land side? Probably not. We do have, I think we're slightly more overweighted towards storage projects now than we have been historically. And we have, from time to time, we do have to think about selling early stage projects or withdrawing. And so that, drop from 4 to 2 is largely a symptom of that. The oversupply of early stage projects, utilities reforming their queues. I mean, when I first started developing our own projects, there were still queues where you could get an interconnection position for, tens of thousands of dollars. Now most, now most, I mean, it's completely different. It's, I mean, queue reform, FERC 2023, that is the sort of the governing statute there. And now that's from regulated utilities requiring a $5 million letter of credit, upwards of 7.5
minimum
for each project, just for a queue position, just to get your name on the list and be in the study process. In many instances, those letters of credit are irrevocable. So the way I sort of describe it, when I started developing projects, we sat down to a $5 poker table. It turned into a $50 poker table really halfway through the hand. And we've had queue positions withdraw. We've had, all developers have.
It went from Thursday night to Friday night really quick.
Exactly.
Right?
Absolutely.
Oh, wait a minute. When did the limits go up on the table?
Absolutely. That's exactly it. Yeah. And so we've seen the short end of that being a smaller shop, but ultimately every developer is focusing and doubling down on their best projects. The highest probability of success, the scale, the market, the technology they like to be in, and maybe they've already got procurement locked up for certain technologies or are really strategic in certain markets. There's only so many developers, sort of the top tier senior developers, that are in almost every state. They do exist, but you will find that most shops have a kind of a preferred market or a preferred focus, and we're certainly no different.
So who's your end user when you're doing a project? And I'm not, don't disclose anything from a competitive standpoint, but just is your end user an enterprise? Is your end user the generation company? Who's asking you to go build a project?
If they were asking us to build projects, we'd probably have a lot more built. So it is a competitive industry. I'll say that.
Right. Understood.
Given how many projects and the speculation and the incentives and how many folks are doing it, it is risk and reward. It's high risk, but it can be high reward on the development side. Our end users are either large users of power or companies that sell large amounts of power, right? So the two classes are effectively utilities and corporates.
That's what I figured. Okay, just want to make sure I understood. Yeah.
When it comes to the utility side, there's often procurement targets, RFPs, utilities that see what's happening with their generation mix, and they're looking to procure different resources, more economic resources. The tragedy of it all is that solar and wind are still one of the more cost-effective marginal new sources of generation, and business works. So when the utilities see that and say, well, you can get me power, great. It's not the exact profile of power that I'm used to, but it's at a great cost. And ultimately, everything flows down from there to the large customers, then the medium C&I, all the way down to the residential. Yeah, generally we're looking at long-term, power purchase agreements with either utilities or larger corporates. I mean, I think there is, at the utility scale, there's been more corporate interest. Historically, there's been a lot of corporate interest with it, whether it's, due to the more ESG factors or just due to the sheer economics. And I think there's more of the latter now than ever before. It's cost effective.
So you mentioned one other thing that I do want to draw us back to, but let's do long-term storage real quick. You mentioned that you've got storage projects and you're in the storage business. Are you designing the storage subsystems, or are you buying them from someone else and using them to provide flexibility to what you've pulled off the sun in a daytime. Where's that long? Tell me the long-term storage story.
Yeah, absolutely. For storage, there are now a lot of off-the-shelf products. There are systems integrators and subsystem OEMs and people designing things specifically for grid-connected battery energy storage, whether or not that's paired with solar or not. When I mentioned our storage portfolio, a lot of it is standalone storage. It's not even paired with solar. And so,
it's not coming with solar.
Oh
okay,
yeah, we've got
it's just storage.
Absolutely.
Yeah. Okay.
And a very different business model for that. There is kind of a different nod to the merchant case and understanding the dynamics of how the multiple different revenue streams from the grid, from a grid connected project, are going to stack up. It's probably still too early. I don't think it's much of a risk on environment for merchant storage projects, but every generation project has to deal with every generation and storage project has to deal with merchant exposure. But when it comes to the components, that supply chain is now pretty robust. It is still mostly Chinese. That is changing as it is, or has in solar. But when you look at these products are now largely fully integrated. Come with all the cooling, suppression, and even containerizing the the PCS and really having it be kind of an off the truck sort of plug and play business. Now, granted, there's obviously you got to pay the right EPC and have your engineers get the right configuration, but it is a much more streamlined and sort of direct to customer product than it was historically.
What kind of capacity can we see, and what kind of duration on long-term storage?
So for long duration storage, and I guess that's a specific piece. You did mention the long duration. There are fewer long duration, sole long duration providers that are using alternate chemistries. So you can create a long duration battery storage project with a traditional lithium ion project. I think long duration used to mean 12 hours or more. It probably is maybe 8 hours or more on what people would consider long duration now. But when you look at the alternate chemistries, the alternate technologies, long duration could be multiples of that. You look at just the different storage technologies that are being developed. There's folks going after upwards of 100 hours. And so long duration being 8 to 12 minimum is probably a good, kind of rule of thumb. Those systems aren't always economical. They are very use case driven. They're sort of, purposefully deployed for specific use cases or utilities that might have specific use cases. There are more of them that are looking at pilot projects for long duration or even beyond pilot projects for long duration. So it's an exciting time to see that develop, but the reality is lithium ion is still king. And if you truly need 8 hours, that's probably the system you're going to deploy.
Got it. You mentioned early in the talk about you're pro the incentives for your particular part of the industry. I will say on the data center side, we know there are incentives out there for solar and for wind, but we don't really understand them. Mm-hmm. Can you give us a 2-minute tutorial on how significant it is? I assume they're all federal, but that might not be right. What's behind a lot of the incentive packages that help to get your projects off the ground?
Yeah, absolutely. So it is largely federally driven, and the way that we do things, that we do it the American way, it's with tax credits, right? We use the dollar to incentivize projects and investors, and that's existed for a while. I mean, this is somewhat of a legacy product or a legacy incentive that's changed over time. When I started in the industry, for example, the tax credits were stepping down and people were discussing strategically how to safe harbor equipment, how to maintain higher tax credits. That was in a world when tax credits were stepping down, 4 to 8% per year and were theoretically going to be fully phased out. I believe in maybe 2024, 2025. Go back to 2022 in the Biden administration. with the Inflation Reduction Act. That's when those tax credits got topped back up. They extended the lead times into the 2030s. And then, of course, go back to the One Big Beautiful Bill Act last year, and that's where those tax credits have been abruptly taken away. Not wholly, but there is now a huge impact on projects, on developers. The safe harbor strategies are top of mind for everybody, and this is, including our projects as well. There's a couple ways you can safe harbor equipment, maintain that tax credit, but I do think it sort of feels like this is the first time maybe the industry is looking to a post-tax credit world in and of itself. And there's pros and cons to that. I think I'm of the mind that we should get used to it sooner rather than later and make sure we can get projects to pencil regardless. And I think there are other parties that feel the same. But the tax credits, they can get complex. The investment structures, the way tax equity investment is historically deployed, the way that changed in 2022. At the top line, what it is, there's really, for renewables, there's two generation projects. There's sort of two classes. There's the investment tax credit, the production tax credit. The investment tax credit is effectively 30% on the total value of the plant, whereas the production tax credit is then production based on how much that plant is generating. And historically, you would see the production tax credits for wind, the investment tax credits for solar, and that's still largely the case today, although those production tax credits can apply to solar as well.
Gotcha. All right, so we talked about the data center business and the energy business and solar and storage. Let's get to the really important stuff. Is Shedeur going to lead the Browns to a Super Bowl?
If anyone leads the Browns anywhere, I'll be happy. And at this point, we've been through.
It would be fair to ask, could Tom Brady lead the Browns to a Super Bowl? I'm not sure.
You're not wrong. You're not wrong. It's the Browns have had it. I mean, I know there's other teams that have had it rough, but I don't think the Jets have a single thing on us when it comes to the factor of sadness that we've managed to produce in Cleveland here with the Browns. It's brutal. Lifelong fan, maybe not even by choice, but it's hopefully an exciting time. They're building a new stadium. That's a hot button issue. People
got a new coach.
We got a new coach. We got a new stadium. I think they're trying to just bridge to that next level of excitement. But when it comes to the quarterback conversation, I know most Cleveland fans will probably have a similar attitude. We've seen it before. It's kind of it's just always enough to keep us interested and entertained, but that's about it. Yeah. So I don't know. God bless.
Well, I remember the excitement about Tim Couch. So I know you guys. I know you guys have been through it, right? I mean, that's 20-something years ago. It's like, no, Tim Couch is the answer. I'm like, no, it's not the answer.
How many? I feel for these.
So you guys, long suffering.
How many of these quarterbacks have we effectively ruined their careers? But that's neither here nor there. I wish the best for all of them and whoever steps into the QB1 position. And beyond that, my football is on Saturdays as a Buckeyes fan. So,
yeah, there you go. All right, Ohio State, I can get with you there. I will give you one ray of hope. So he's retired now, but he was the head of marketing here, Steve Flagg. He was a longtime Detroit Lions fan, and that program finally got turned around.
Absolutely.
So I mean, the Lions, who I think probably held the distinguished position of the worst franchise in sports, they figured it out. So it can be done.
Well, now they passed
I think it takes some real fundamental changes. That's right. Well, you and the Jets are fighting it out, in fairness, but the long-suffering Lions fans, they've had a good run here the last few years, so it's possible. Well, Dan, thank you for talking with us about solar. It's certainly an area we're aware of, but not terribly well educated on. Didn't really understand, and we appreciate you sharing a little bit and helping us understand better. And man, our industry is pretty power hungry. So get out there and get into building some stuff, because I'll tell you, we need more.
Absolutely, and I appreciate it, Raymond. Thanks for having me, and we'll do our best, and always happy to be a resource.